This presentation is based on the questions. So one of the questions was about the formulation of the gel, and I'm showing you here the example of difference in results obtained between tris glycine and tris acetate gel, and this is like a refining step of the Western blot procedure. If one wants to increase the sensitivity or want to get better results, the gel formulation may be of importance. Why using precast gels was one of the questions. Precast gels can actually are prepared in controlled conditions and can give you higher reproducibility. Sometimes, depending upon the temperature, if you're casting gels yourself, there can be differences in how the gel is polymerizing. So if there is a possibility, and if you're using, if you aim to do quantification, then using precast gels may be helpful. But of course, self-casting works very well if we mastered that technique. What should be loaded per well? That was also one of the questions which I received. Protein, chlorophyll, or volume. Recommended is microgram of protein and microgram of chlorophyll, and this is what I hope you're using. I'm terrified to see that volume is used as loading is done on volume. So 200 milligram of tissue is extracted, and then how much protein is loaded per well, nobody knows. And there are reagents which will allow you to measure protein concentration in presence of different components of extraction buffer containing detergent or denaturants and reducing agents and so on. So this is not an excuse to skip the step of estimation of protein concentration. If you're loading on volume, I don't understand how one can compare the samples, the lines in between each other when loading on volume, especially when doing manual protein extraction. There can be a difference between the samples in how well a sample is actually extracted. So I really hope that you're loading your gels based on protein. If you're working with photosynthetic tissues, you can use chlorophyll. How much material should I have? Should it be nanograms or micrograms? It will also depend, of course, with what protein you aim to visualize. If you're working with a recombinant protein and you want to check expression level, then it's nanograms. Otherwise, if you use chemiluminescence, it can be too much of a signal coming up. One can do a titration. So you can do varied protein load per well to find the best signal to noise ratio with least background. Of course, like in this example here, there was the same protein load per well, but the antibody was used in higher dilution, which diluted away the background. So please remember that if you load too much, of course, that can contribute to also increased background. It's a very fine balance here. Should I use 1D gels or 2D gels? It depends what kind of biological questions you are aiming to answer. Just a reminder, one-dimensional gel electrophoresis, then all proteins in a complex mix, which we are loading here to the well, are separated and migrated in a gel, which has, which is often having a different percent, and which means that proteins which are larger will get stuck faster, and those which are smaller will migrate lower down the gel. And please remember that each such band contains hundreds of proteins, right? this is of a similar molecular weight, because we're working with a complex mixture which we are analyzing. So this is so-called one dimension, and it has no PI limits. But sometimes we want to know how many proteins and which proteins are actually in this band. And therefore, then we are using a two-dimensional gel electrophoresis. And one can also do Western blotting on 2D gels. It is, however, less common. But it is another way to analyze proteins. It will allow us to by analyzing the spots, we are analyzing hundreds of proteins at the same time. So that's another methodology.